right, today we're going to learn about proportions. All right, your objective is to understand proportional relationships, and this is page 32. Now, a lot of times when you get to word problems, part over whole is going to really help you. This is one of the other things that is a very common strategy that can be used to solve problems, which is proportions or proportional relationships. So first of all, what is a proportion? It's a statement that two ratios or rates are equivalent. Okay, you can think of it like equivalent ratios, equivalent fractions, proportion. It all means about the same thing. It just means that this side is equal to this side. So one way I can tell that these are equal is I could take this side, which is already in simplest form, and then I could look at this side, 2/6. If I reduce that, I also get 1/3. So that helps me to know they're equivalent. Also, I could think about cross products. If I multiply 3 times 2, I get 6. If I multiply 1 times 6, I get 6. So that also tells me that this is a proportional relationship. So if I want to know if something's proportional, I'm really just looking to see, is this side equivalent to the other side? Okay? Now, one other way that you can look at this or tell is scale factor. Scale factor is a number that describes how much smaller or larger a ratio is from another, or a rate, or a fraction, etc. So basically, in other words, we've used this, we just haven't really been calling it scale factor. How do we get from here to here? Well, from 1 to 2 is times 2, and from 3 to 6 is times 2. So because this number right here is the same, then I know that these are, in fact, proportional, okay? Aside from testing, reducing, or doing cross products, I could also check how do I get from each one to the other, and if the scale factor is the same, then I know that it's also proportional or equivalent. So 2/6 is 2 times larger than 1/3, as in getting there times 2. Technically, they're the same value though, because I can reduce them both to 1/3. Okay, so now we're going to find a missing value, and we're going to do that using scale factor in our knowledge of proportional relationships. Okay, so I don't have the other number up here, so I don't know how I'm getting there. So I have to look at the denominators. How am I getting from 4 to 28? Well, proportions are only multiplicative relationships, so you can't add something or subtract something. I can only multiply or divide to get to the other number. So in this case, it's getting bigger, so I'm multiplying. And 4 times 7 would give me 28. Because my scale factor has to be 7 times 7, that means up here would also be times 7, so that it's actually equivalent. Well, 3 times 7 is 21, so x equals 21. And my scale factor would be multiplying by 7. All right, look at this one and see if you can figure out the scale factor and what our missing value is. All right. Again, I don't have the other numerator, but I do have both of these, and I can see that it's getting smaller, so that means I have to be dividing. If I divide by 4, I get 5, so my scale factor is dividing by 4, and so this has to also be dividing by 4, and 8 divided by 4 equals 2. Okay, so that means my missing value is 2. Now, one thing to note, when you're dealing with proportions, you can look for relationships up and down and side to side, okay? So for example, 8 is smaller than 20, so I know that whatever goes here should be smaller than 5. And if I look side to side, 20 is bigger than 5, so I know 8 will be bigger than whatever I get here. So that's a way to check and see if the answer you get is reasonable. Well, 2 is smaller than 5, so that makes sense, and 2 is smaller than 8, so that makes sense. If I look up here, from top to bottom, 3 was smaller than 4, so I know x should be smaller than 28, and it is. And if I look side to side, 4 was getting larger to 28, so 3 should be getting larger, and it is. It got larger. Okay, so that's just a quick way to just make sure you didn't accidentally do the opposite of what you're supposed to do or get something crazy. All right, now let's look at a word problem. If Ollie runs 3 miles in 36 minutes, how far can he run in 60 minutes? All right, so something really important to remember when you're doing proportions is to look at the units. Whenever you're setting up your proportion or setting up what looks like your equivalent fractions, you have to make sure the units match. So if you put minutes on top, then go ahead and put minutes on top on the other side. If you put miles on the bottom, you need to put miles on bottom on the other side. If you accidentally switch these, it's going to throw off your proportion and not help you find the right answer. Okay, so I'm going to read my sentence and take what first two things were paired together. It says, if Ollie runs 3 miles in 36 minutes. These two things are told to me together, so they are taken out and put on one side. So 3 miles, so the 3 would have to go down here with miles, 36 minutes. All right, now how far can he run in 60 minutes? Because the minutes is on top, the 60 will go up here, and I'm looking for how far, so this is my x, or my unknown. Okay, now, one way I could solve this is I could look for scale factor. How do I get from here to here? Do the same thing here. But in this case, it's not very obvious to me how to get from 36 to 60. So I'm going to teach you another strategy, and this, scale factor works when you can identify it, but this strategy I'm about to tell you works on every proportion, so it's great. And I call it bat and ball. Why? Because that's how it looks. So what you're going to do is you're actually going to use your knowledge of cross products. You're going to first start by circling the two numbers that are diagonal of each other. You see how we didn't have a number here, so I can't circle these two, but I did have both of these numbers, so I circle that. Well, that's like my bat. Okay? And then this, I circle the other number, the third number that's left over. This is like my ball. Okay? So it's called bat and ball. What I'm going to do is the bat, I'm going to multiply. So I'm going to do 60 times 3. 3 times 0 is 0, 3 times 6 is 18. So that equals 180. Well, because I know that whatever I get answer here should give me the same answer here, that's why this works. I know if this gives me 180, then when I multiply 36 and this missing number, it should also give me 180. So to find what the missing number is, I do the opposite and I divide. So I'm going to take 180 and divide by 36. So in other words, I multiply the two numbers that are diagonal and then I divide by the third number. Okay, so 36 does not go into 1 or 18. So now let's think reasonably. Maybe 5 times. Let's see what 36 times 5 is. 5 times 6 is 30. 15, 16, 17, 18. Oh, perfect. So that would be 5, which would be 180. So that tells me that he can go 5 miles in 60 minutes. Now, one other thing that I can notice here is that, remember we look at relationships from side to side? I could also look at a relationship from top to bottom. So 36 to 3, you might have realized that 36 divided by 12 gives you 3. So you could have also done 60 divided by 12. Whatever you do to one side, do to the other. And that would have also given you 5. But again, if you don't automatically see the relationship side to side or from top to bottom, bat and ball will work for all of them. Okay. Let's look at another situation. The distance between Clark Junior High and Huddleston Intermediate is 3.5 inches on a map. Use the scale below to figure out the actual distance between the two schools. And here's my scale. It says 1 inch equals 150 feet. So first of all, the easiest thing to do is first pick out what are your units. What are the two things you're comparing? Well, we are comparing inches and feet. So I'm going to start off, because I know I need to make a proportion to set this up, I'm going to start off by just making a proportion with nothing in the blanks, and I'm going to put my units in. So inches and feet, and if I put inches on top, I need to put inches on top here, and I'll put feet on bottom here. Okay, so now let's see what I know. Well, I do know that these two numbers go together because they're off my scale. So I'm going to put 1 inch here and 150 feet here. Now, what else do I know? I know I have to at least know one other number and then be missing something. So the other thing it told me is that from Clark to Huddleston is 3.5 inches on a map. Well, where am I going to put the 3.5? Well, I have to put it on top because it says inches. 3.5, which means this is my x. Now, how can I solve this? Well, I can look for a relationship side to side. I could look for one top to bottom, or I can use bat and ball. And since this works for everything, I'm going to go ahead and do that just for practice. So, bat and ball, 150 times 3.5. That's 0. 5 times 5 is 25. 5, 6, 7. 3 times 0 is 0. 3 times 5 is 15. 3 plus 1 is 4. 0, 5, 7, 8, 9, 10, 11, 12, 5. Now don't forget you were multiplying with a decimal. You have one decimal spot, so you have one spot and then your decimal goes there. So that would be 525. And then I do the ball, which means I divide by 1. Well, guess what? When I divide by 1, the number doesn't change. So my answer would be 525 feet. All right. Now let's read the next one and see if we can come up with a proportion. The sprinkler system at my house has 9 watering stations. If it takes 52 minutes for the first 4 stations, how long would it take for the remaining stations? All right, so first of all, I need to make sure I realize that it says remaining stations. It's not asking me for the total stations. It's not asking me for these 4. I want to know what the remaining is. So I can actually use part total to help me identify what I know. Okay, so I know that there's 9 watering stations total, so that would actually be my total. I know that 52 minutes is for 4, so 4 stations would be a part. So what's the remaining, or what's the other part? Well, 9 minus 4 is 5 stations. Okay, so, and I know that these 4 stations take 52 minutes. And I want to know this. This is my unknown. Does it matter how long all the stations take? No, it didn't ask me that. So I don't have to worry about that. Okay, in fact, I don't even need this 9 anymore because look, if I cover this up, you can kind of see we almost already have our proportion. We have 4 stations, 52 minutes, 5 stations, blank minutes. Okay, so now I can set up my proportion. Again, what are my units? My units are minutes and stations. So I'm going to put minutes, stations, minutes, stations. And it doesn't matter if you put stations on top and minutes on bottom, you can still do that and still do the proportion correctly and get the same answer. Same thing up here. If I put miles and then minutes on the bottom, or feet on top and inches on the bottom, it doesn't matter. As long as they match side to side, you can do it either way. Okay, so now let's see. I know that 52 minutes are for 4 stations, and I want to know the remaining, so I want to know how much for 5 stations. And this is my x. Okay, so now I have a proportion. Again, I'm going to make some observations before I actually solve this. 52 is larger than 4, so I know this is definitely larger than 5. And from 4 to 5, 5 is a little bigger than 4, so I know that this should be a little bigger than 52. So if I get something really big or smaller than 52, I know I did something wrong. Okay, so again, I'm going to use bat and ball to solve this because I'm not really sure how to get from 4 to 5 multiplying by something, and maybe it's hard for me to tell from 52 to 4 also. So, in this case, the two that are diagonal are now right here. And my ball would be this one that's left over. So 52 times 5, 5 times 2 is 10, 5 times 5 is 25, 26. And then I divide by the ball, which is 4. 4 does not go into 2. It goes into 26 6 times, which is 24. I was thinking 24. Okay, and that's 2. And then 4 goes into 25 times, so that would be 65. So in other words, it would take 65 minutes. Now, is that answer reasonable? Well, yes, because it's definitely bigger than 5. And from 52, it got a little bit bigger. Also, you could look from here to here and go, well, how did I get from 52 to 4? Or backwards, how did I get from 4 to 52? That would be times 13. So 5 times 13 would give you 65. So you can find relationships other ways. But again, bat and ball, it's always going to work as long as you set up your proportion correctly. And when in doubt, if you are given 3 things like here, and then you're missing one, then there's a good chance it's probably going to be a proportion. And watch out for stuff like this, part total. What I have is a lot of people try to use 52 and 4, and then they take 9 and put it here, because that's the other number they see. But you got to make sure that whatever you're given matches what you're being asked for. So be careful and use part total to help make sure that the things in your proportion are actually the things you need to be using. All right, guys, keep practicing. See you next time.